Okay, so my name is Jonathan Feldstein, and I actually work on the WebGL implementation for the playbook and upcoming BlackBerry 10 platforms. So yeah, so we're actually one of the first implementations of WebGL on tablet devices, which I think is actually really exciting. So one of the things that we did is we created just a very simple piece of content to try and showcase our WebGL implementation on the playbook platform. It's this game that we call Tunnel Tilt. It's also available in open source land on GitHub, and you can even play it in your favorite browser. It's all completely open source and available. So I'm just going to demo it. The cool thing is this is just what we call a WebWorks app, which just bundles up HTML5 content and enables you to eventually sell that content on our app store if you so chose. So here's Tunnel Tilt. Assuming it works. Oh, I guess volume's not supported. Oh, it's really dark, but hopefully you can see some of it. If anyone wants to see the game afterwards and play with it, feel free. So the cool thing is that I'm tapped into our accelerometer APIs on the device, and as you can see, it's basically like running a native application, but this is not a native application. This is a web app.
It's built on, you have a WebKit stack on it?
Yeah, so our browser, our company had acquired a company called Torch Mobile, which is actually one of the largest suppliers to actually WebKit, like they're one of the big players in WebKit. And as a result, our WebKit stack is actually quite good, and we're always looking to optimize our browser, and WebGL is just another one of the facets of that browser experience. Yeah, obviously because it's part of this open community, we're going to be eventually providing our source code back to the community as well. It's obviously on our list for sure. So that's what we're hoping to do. We also have like several other examples. Like I noticed Mr. Doob, or for those of you of 3JS notoriety is here. So like we have other demos, for example, that showcase some of that technology as well. So this is like, for anyone that's familiar with 3JS, you've probably seen this demo somewhere. So there you go. Yeah. And yeah, so if anyone's actually working on any interesting WebGL content, we're definitely very interested in talking to you guys and trying to make sure that your experience at our platform is as amazing as possible. So yeah, that's pretty much it.
That's rocking. When is that going to be released?
It is released. WebGL actually works in the browser as well.
So this is not my demo. This is a demo from Opera, but they were showing it at the MWC last week. They launched it. So this is our production browser 2. This is running on a Tegra tablet. So this is it is interactive. You can make him rotate or walk. But this is interesting in that this is a relatively complex model. It's like 40,000 polygons in this model, and their production browser now on the Android market is shipping with WebGL. Cool. That's it.
That's great.
So I'm Klumpp with Microsoft. We make a bunch of graphics products, one of which is Poser. I actually didn't prepare a demo. Tony just called me on the way in. But I do have some fairly heavy-duty content exported to WebGL and showing in Chrome here actually. So since there was talk about Collada and how to go from that into the browser, I just wanted to show that even though the Collada working group and Collada users, the drivers out there, think there's possibility for improvement and things need to be done, I just wanted to show that it is possible to take fairly heavy non-web optimized assets like this figure that's about probably 20,000 polygons with textures and everything. I took that, pulled it out of the content library in Poser, it's included with the product, generated a walk for it in the product, exported it to Collada and loaded it up with GLGE in the little viewer app that is in GLGE, and it actually runs in Chrome very well at interactive frame rates. So I think it's really just a little proof of concept, but it shows the potential and it shows where we've arrived. First time I tried this, it wouldn't run in any browser at all. Second time I tried it, I got like 5 frames per second in Chrome, and since last SIGGRAPH it actually runs interactively, so it was really nice to see how the performance progressed in the implementations, and now it's actually quite robust and quite impressive. So that's it. Thank you.
Right. So question for you. So is there planned product? Is this still sort of experimental?
Well, the product shipping Poser Pro 2012 has Collada export, so it exports rich.
Is it this Collada? Did you have to tweak the Collada?
No, it's not tweaked. You can do this. There's features to prepare the meshes a little bit for export, just if there's issues with the weight map conversion or whatnot. Then you just write out the Collada file, and then you have to get that into the browser somewhere. I happen to use GLGE because it was well suited, but I imagine there's other frameworks as well that could pull this off. Certainly, the implementations are not good.
So not to put you on the spot, but how are things going with the Collada loader? I haven't checked it out in R47, but I was having some serious issues in R46. So like the only thing I was reliably loading was OBJs that I was using recently in a project. So I was wondering what, if any, plans you have on that.
Well, it's getting the thing is like something that I always say, like on Linux, there's always like a 60% of code is for like drivers. Like for 3.js, like 60% of code is for the Collada loading. So I can give you an idea of, we were tweaking things and we are learning how.
Are you looking for active help on that? Do you need more resources?
Like anyone is free to help.
Yeah, we should all talk about that then.
It's because we don't really, I'm sure there are specs, but we don't really know exactly all the options. And we just have like test files that we try and we find something that doesn't work and then apply it.
Yeah, I mean, we did this art hack this last weekend. We had 9 people together in a room. We didn't know 5 of them when we got there. 4 of us were friends. We said we're going to build something on top of 3JS and WebGL. And we built a little MMO in 2 days with a multi-user server with Twitter integrated, a cute cartoon shader that fellow Don Olmsted, raise your hand, Don wrote. But it was all sort of static OBJs. I hand animated some clouds slowly drifting around. But we had the OBJ loader and we could push stuff through that way really reliably, but we really wanted little people moving around. All the characters were just standing there with little balloons over their heads. So it'd be great if we could start unleashing that part of the pipeline. I think we're gonna see great stuff real quick, and Poser users will go to town once that stuff's really working. So
Certainly, yeah.
I'd be really excited about it. Do you guys still do the other modeling tool as well, Shade? Is that still a product?
Not anymore.
So it's mostly about Poser.
It exists. It's been distributed in the US, but it's not the same company anymore.
I see. I got it. So it's mostly about Poser still.
Yeah, and Anime Studio for 2D, but there's no WebGL path yet. So.
Got it. Great. Thanks, Uli. That's great stuff. Demo. So
What I'm going to show you here is recycled content. 5 years ago, we built a history CD for NASA. And part of it was a virtual walkthrough of Hangar 1 down by Moffett Field and showing some of the aircraft. We used a Vermal viewer, the parallel graphics viewer, for this, and NASA procrastinated on shipping it until 5 years later. They call us up. Parallel graphics no longer makes a Mac viewer, so we had to look for alternatives. And we decided to just try putting it all into WebGL and see how it would run. And lo and behold, this is meant to run from a DVD, but we stuck it up on the server for test purposes. So run a little bit faster on the final thing.
You're running my data time right now.
And
You meet her?
and while we're waiting for this, this is like a 10 polygon model, and
It's like NASA models.
it looks like stuff is really.
But that's an interesting question. How big is it?
It's pretty tiny, but it was optimized for DVD, so it wasn't super optimized. I guess I can try something else here. It could be this little netbook too. I don't know. I'm in Chrome, so it should be running fine.
Sorry for putting you on the spot with this Dave. Your little netbook.
Yeah, and the WebGL sound works just fine. And the rest sucks. Okay. I should have tested it before coming here.
Sorry, I want to show the other thing you said you wanted to show off, that you're porting to WebGL, so that's not going to work.
Well, yeah, let me go to the end of a PowerPoint here. Now, we've got another project that we're working on. We've built a lot of multi-user systems for cell phones and mobile devices of all kinds, navigation systems. But my background, early on, I practiced architecture. I used to build some of these big buildings here in town. We're closing the loop with some of my old friends who are still building buildings. They're architects and engineers. And the reason we're doing this is because we bought a laser scanner last year. And let's see here. Trying to find the slideshow button on this interface. Does anybody know what it is on this one?
That stuff will be sweet.
No, it's right in front of me here. Right? Up. Oh, the slideshow there. Okay. Okay. So this was a slideshow to explain laser scanning to our architect friends. I'm going to go through this pretty quickly. We started building using 3D interfaces in what the architects now call building information models, BIM models. Now, these BIM models are mostly being built by the architects in an Autodesk product called Trevett. It's a solids modeling program that does really crappy 3D models, but they want to put these models online for sharing. There's an Autodesk person here. So made that sound. But they make huge models. We're working on a model right now, it's 350 megs. But the good thing is that people have made a multi-user open source server called BIM server. And it reads and writes Collada and IFC and things like that. And fast forwarding through some of the laser scanning stuff that we're doing for the architects to get to this interface that we're calling BIMBOP. So this is a tablet-based interface for architects, engineers, building managers, contractors to take these interfaces and use them on a tablet out in the field to collect data, manipulate the data, and it automatically saves back to the server. Well, the cool thing is this open source BIM server that we're using supports WebGL. So it's an early implementation of it, but you're seeing some of this technology creep into even my old Luddite friends in architecture's lives. So good things ahead. Now, BIMBOP will have a 3D interface in its next generation, but it's running on Android and iOS right now. So that's it. Enough finger sharks. Thanks.
Good job, man. Thank you.
If you go to the Intel booth at GEC tomorrow morning, he's not going to be there all day, just in the morning. Look for River Trail, and he's got, it's sort of like we were talking about before, with multi-threaded JavaScript extension, and he's running, a side-by-side demo of like a particle system under standard WebGL, and with his thing, it's running at like 40 frames a second. And it's
When you say JavaScript extension, what do you mean?
apparently it allows you to do multi-threaded stuff that you can't do with standard JavaScript. I'm not sure the details.
You know what he's talking about?
Yeah, so Intel's River Trail is it's kind of like a JavaScript language extension. It defined one new data type called parallel array, which is a read-only block of data. And then they can basically take a JavaScript function and magically compile it so that it runs in multi-threaded fashion. It's pretty neat. They had an OpenCL backend for it at one point, and I think now they're focusing on CPU compilation of the JavaScript kernels. It's kind of like it's a counterpoint to WebCL, where WebCL is exposing very low-level primitives, and River Trail is more JavaScript-centric. But it's a pretty interesting project.
Hi guys, my name's Chris. I work for a company called Firebase. We have a really cool, very simple API to enable real-time communication. So if you're a WebGL developer without a lot of back-end experience, you can make these really cool, interactive, real-time apps. So this, you guys may be familiar with this library. It's a 3JS Hello Enjoy demo of a Ferrari. But what we've got here is actually a controller, and we're gonna drive it around. This is all in the browser here, so we have HTML5, we're getting the accelerometer data, we're using the touch to control throttle. This has got 2 lines of JavaScript that talk to 2 lines of JavaScript over here, and that is the extent of the the back end. So
IP
yeah,
network?
what? Oh,
That's
so
IP
we're
network?
we're going over the Wi-Fi with these, both of them. If you had an iPhone, you could do it with your 3G. You can do it on certain Android phones. We're still testing it, as a quick hack. But yeah, these are not Bluetooth connected. This is all over the
It's going
internet.
over the WAN.
Yeah. So
Going out there and coming back.
yeah, exactly. And so it's a yes,
over your
data. Yes,
Your
exactly.
sport.
Yeah. So that's a cool demo. Any questions, I guess?
We'll tell people about Firebase. I mean, is this
Yes.
part of what you guys do?
Yeah. So Firebase, we just launched. We sponsored Angel Hack. I don't know if you guys are familiar with it.
Yeah, we
had-
lost Angel Hack, so I know about it.
Yeah. So we had about 400 hackers in a room, and they competed. They had 2 days to build a cool product, and we launched Firebase there. We had half of the winning teams using Firebase at the end, which is kind of cool. But essentially with this, it's a JavaScript library. So so with this, we included JavaScript library. I made a variable for the accelerometer data and for the throttle data, and just plugged it in over here. We have a nice simple REST API too, so if you don't want to use JavaScript, but it works very well in WebGL. So yeah.
So what kind of latency are you getting?
Right now it's not too bad, but we measure in the milliseconds,
Uh-huh.
so it's pretty quick.
Show us again.
Yeah. So honestly, this is probably the worst demo because there's no context once you leave the beginning. Oh, and in fact, that's what I get for refreshing.
Reloading.
Maybe. But yeah, no, latency is good. You can kind of see it moving around. We handle, so we were born from a chat company, and our chat product is on 50,000 websites, and we handle 500,000 messages a day. So we took everything we learned about real-time communication and built this cool API. So yeah,
Awesome. Chris.
and we love WebGL.
Hey Ken, we got one more before you come up and do your thing.
So,
Introduce yourself, David. We need to get him on.
I'm David Sheets. Hi. I work for Ashima Arts, and we're a pretty small company, a couple people. I'm the primary developer. Been working there for a few years. Anyway, we released this game last year. Pretty basic. The big thing was the rigid body motion, quaternion camera control, this sort of thing. And we wanted to share numeric code, both, I don't know what's going on with the network here, share numeric code both in JavaScript and in shaders. And our big issue there was the shading language. So, the past few months, I've been writing a compiler that consumes GLSL and outputs JSON format stuff. So this is a big JSON block. It's tagged up with symbols going in and out. You can see here it notices that S noise is coming out and a few symbols are coming in. It takes care of the preprocessor. Preprocessor directives and preprocessor macros are first-class symbols. And you can link these together in about 2 kilobytes of gzipped JavaScript. I guess I don't have network access. I'm still on H honors.
Go to Neil Zoom.
There we go. Okay. So in doing this, I found a lot of bugs in a lot of people's preprocessor implementations and various other shader language implementations, as to be expected. Most people don't care about the preprocessor. We sort of see fragments of GLSL as a subset of JavaScript, a subset of OpenCL, shading language, these sorts of things. So I'm only going to write this code once, and I'm going to compile it and run it as many places as I can, and I'm going to try to share it with as many people as I can. For instance, the noise textures that you saw on those platforms use no textures, use no arrays coming in. They're entirely ALU operations. So as bandwidth becomes more and more, very few textures here that are loaded. If you had a game with real artists who actually produced assets, then you'd have more textures and you would be hurting for bandwidth. So when you have excess ALU operations, you can burn some of those on doing this sort of noise stuff. We'd like to share this. We'd like everybody to use these noise functions. We'd like them to be as good as possible. And to do that, we need modularity for these sorts of functions. So that's what this is for. And we can do all kinds of nifty things, make some buffers. It's originally a command line application, as a compiler should be. So you can integrate it into your tool chain. You can reference whatever you want, and we'll notice that, let's just say we need an A and B. Oops. It's still buggy, not been officially released. I'd love to hear people's input.
It's live now though, we can go download it?
Yeah, you can go there. It's on GitHub. It's at ashimagroup.net/glock. The idea is that it's going to be open. This language is going to be open for everyone forever. It's just as important as JavaScript or CSS or HTML. I'm going to keep building compilers to compile between every different dialect that anybody comes up with. So it's BSD licensed. Other questions?
Awesome.
Yeah.
How is the binding between the shader and the incoming data managed? Is that in the metadata?
Which shader? Or which data?
Well, I mean, basically in OpenGL, you've got vertex buffers that feed in data into shaders. So how is that? But that's the program code, right? The OpenGL ES API calls are made in order to set up that binding. So how is that intended to be managed?
So I presently don't make that decision for you. This is entirely source level manipulation. So I type each individual source fragment and make it into sort of like a module. There are no data types that get propagated into the object format. So you could still have type errors later if you're not careful. I also type the various pipeline stages. So I know when you have uniforms that you need to have incoming, and eventually someone will write the binding so that there's a validation check to make sure that those uniforms are present. I know when you have outgoing varyings, incoming varyings, these sorts of things.
So we can take that and condition that and output the 3JS structures that Ricardo has in his library, for example, right? You're generating something that's intermediate, right?
Yes. I don't currently do it, but you could easily consume GLSL structures and produce getters, setters in JavaScript. You could do it, and you could serialize those structures and push them over the network as well. Though that hasn't been done yet. This has been several months just to get. This is like byte level accuracy, right? Things are tracked correctly. The line numbers are tracked correctly. I intend to build world-class open source compiler tools.
So does it run everywhere?
So this is running right now in a browser, compiled to JavaScript from OCaml. It also runs natively in OCaml.
All right, David. Thanks a lot.